Significant figures are basically, we use significant figures for measurements. Okay, so that's mainly why we use sig figs. I won't call it sig figs for short, but we use significant figures for measurements. Okay, and the way we look at these is we have a certain measurement, and then we have an uncertain measurement, uncertain digit. Okay, so for instance, if I got 1.2, right, 1.2. And let's say, right, this 1.2 is 1.2 grams, trying to measure out this pistachio nut on this scale here. So right now we can see, right, for every red line, this means that it's going to be marked 1 gram. Okay. And I'm going to estimate that, okay, this line here where it's saying this pistachio is a mass for is 1.2. That's my estimating. Okay. And once again, this is how we have to think about measurements, right? Because I see that red line is 1, and I'm estimating this 2 here, that next digit over. Okay, that's the uncertain digit, the estimated digit, okay, for our measurement. Because I know, right, it's after this red line is 1 something. It's 1 something. And since it's very close to that red line, I'm going to estimate that it's 1.2 grams. Okay, so this is our estimated reading of this pistachio right here. Now, this is very important. This is very important. Just a side note, right? What's the difference between 30 milliliters and 30.00 milliliters? Okay, it's all about that last digit, right? Because that last digit is going to tell us a lot. It's the difference between the two here. So this 30 milliliters, right? If I want to go up or down, right? Because of though the digits that's not here, right? It's only 2, right? This means I'm going up and down by 29, right, milliliters to 31 milliliters. I'm going by 1. So because it's 2 decimal places over, right? If I'm going down or going up, right? If I go down, it's going to be 29.99. And if I go up, it's 30.01. Okay. So this is just something you want to pay attention to if you are ever looking at sig figs or really any type of measurements, right? Because that matters how it's marked. Okay. If it's marked by just showing 30 milliliters, it's going to be different how you read that measurement. If it's marked 30.00 milliliters, then it's going to read your measurement a little bit different. Now, with significant figures, all right, there are rules to this. There are rules to this. There's really 3 rules I will go over with you guys. Okay. So first rule, all non-zero digits are significant. Okay, all non-zero digits are significant. So once again, sig figs, we're talking about measurements here, only measurements here. So that means that my 1, my 2, my 3, my 4, 5, 6, 7, 8, 9, all significant figures. All right, 1, 2, 3 into the 4. Okay, you know what I'm saying? Shout out to Snoop Dogg. Okay, I'm just y'all don't know, man. I love music. I love music. Okay, so all of these are significant figures. They're all significant figures. Now, let's look at rule 2. All zeros between 2 non-zero digits are significant. Okay, so for instance, we got 3005. 3005. Okay. 3005. How many sig figs would you think this has? Right? And think about this rule. All zeros between 2 non-zero digits are significant. So because with 3005, we have 2 zeros. Now, normally, as I said before, in rule 1, right, if it's a 0, it's not significant. It's not significant. But because it's in between our 3 and our 5, okay, 3 and 5, 3005, shout out to Charles Gambino, 3005, okay, These two zeros are significant, okay? Because they're in between our 3 and our 5, okay? So because of this, we actually have 4 significant figures. 1, because the 3 is always going to be significant. 2, because the 0 is in between 3 and 5. 3, because the 0 is in between 3 and 5. And then we have 4, because, well, 5 is a significant number. So we have 4 significs here. And then rule 3. All zeros to the right of both a number and a decimal number are significant. So everybody, please pay attention to this one. This is usually the one that is the most confusing. All zeros to the right. So it must be towards the right, not towards the left. To the left, to the left. You know, I'm going off with my songs right now, y'all. I'm killing it. So it's towards the right. Towards the right of not only a number, but a decimal. Okay. So if you look at this example here, 9.900000000, right? This number here, because we see, right, it's going to have 9 significant figures. Let's talk about why it has 9 significant figures. 9s are always going to be significant. That goes back to rule 1, right? But rule 3 states if it's towards the right of both a number, so my zeros are towards the right of a number. Here's my 9. So that's the check. That's the first check. But it's also a decimal here. There's my decimal. That's the second check. So basically, all of these zeros towards the right are going to be significant because it's towards the right of a number, 9, and a decimal. Okay? So we have 9 significant figures. Now, for instance, let's say, right, this decimal was not here. It's gone. So would these zeros be significant? No, they would not be significant at all, right? Because the zeros are towards the right of a number, but it has to be both a decimal too. And if there's no decimal here, right, these zeros are non-significant. So everybody, please remember that. In order for your zeros to be significant, it must be towards the right of a number and decimal. Okay? And these are the 3 rules when it comes to counting significs, right? The first one you want to pay attention to, which is the one that we should, the first one's going to be easiest to remember. Basically, if it's 1 through 9, it's going to be significant. Number 2, all zeros that are going to be between 2 non-zero digits are going to be significant. Okay? And then rule 3, if you have zeros that's towards the right of a number, but also a decimal, then they are significant. If it's not a decimal, right, they're not going to be significant. Or if it's not a number, you have to have both, right? Exact numbers have no uncertainty and thus do not limit the number of significant numbers. Unlimited significant figures. That's how we have to think about exact numbers. There are unlimited significant figures. So usually the things that fall in place for exact numbers, okay, usually if you're counting, so you're not measuring, okay, so basically, right, Elmo, whenever he's counting 1, 2, 3, okay, those are exact numbers. You're counting. Measurements, right, if you're trying to measure your mass or something like that, you have to use significs in this case. Constants and formulas are exact numbers. So, for instance, right, the 2 in this formula here is an exact number. Exact number. No significs needed. And then definitions. So, if I know that for every 1 inch equals 2.54 centimeters, this is an exact number. Okay, it's an exact number. So it's defined. 1 inch equals 2.54. Okay, so these are your exact numbers. So our number is 0.004004500. Okay, let's go through this entire number and break it down one digit at a time. Okay, so this 0 here is not going to be significant. Okay, it's a 0, right? It's just like, think of it as a placeholder. That's what it is. It's just here for a cosmetic purpose, as it says. It makes it look nice. It makes it look pretty. You don't want just a 0.00. You want that 0 there. Okay, so 0 point. It's not significant for a couple of different reasons. The main reason I'm just going to say is that, notice right, it's not towards the right of a number or a decimal. Bam. It doesn't meet the rules, so it's not significant. It's not in between a non-significant number, so it's not between 1 and 9. Okay. Let's look here. So now we go from 0 decimal 00. So what about these, right? These are not significant, right? Zeros used only to locate the decimal point, so they're just placeholders. Now, Dr. J, what about rule 3? It's towards the right of a decimal. Right, you are correct. You are right for saying that. Now, what's that other rule 3 say, though? It must be towards the right of a decimal and a number. Because there's not a number here, right, 1 through 9, these are not significant figures. No number, not significant. Let's look at these. So I got my 4 here. 4 is significant. Why? Because it's a non-zero. All right, so that was the easy one. Let's get these zeros. So once again, 0, what are we thinking here? Well, let's go to rule number 2. All zeros between non-zero numbers are significant. So because they're between 4 and our next number, 4 here, these are all going to be significant zeros, significant numbers. Okay. 5 will be significant. And then let's go to the very end, 0, 0. Okay. And these are going to be significant. Now hold on before you talk. Let me explain. All right, so these are significant because of rule number 3, right? Even though there's not a number after, that's okay. These zeros are towards the right of a number. Here's my 5. But also, the zeros are now towards the right of a decimal, okay? So this is when, right, they're significant. It's towards the right of a decimal and a number right here.